Hey guys, Mr. McKinney here, just going through the cone water problem in case you missed class today or if you needed to see it again. So this is similar to the pyramid problem, but it has a couple of slight differences. So it tells us that the diameter and the height of a conical paper cone are both 4 inches. So we know that the diameter is equal to the height at all times. The water is leaking out at a rate of 0.5 inches cubed per second. It's a rate, which tells me it's going to be a fraction. Inches cubed is a way to measure volume. Seconds is a measure of time. So this is giving us dV dt. And since it is leaking out, I would say that we have a negative rate of change of volume. So dV dt is negative 0.5. It's asking us to find the rate at which the water level is dropping when the diameter of the surface is 2.4 inches. Now we also know that the diameter is equal to the height at all times. So this also tells me that the height is equal to 2.4 inches at that time. And it's asking me to find the rate of the water level. The water level is going to be considered the height on this problem. So we're trying to find dH dt. The most important part on these problems is setting it up and figuring out what they give you and what they are asking for. So they're giving us dV dt and they're asking for dH dt. We're dealing with a cone, so we know we're going to need the volume of a cone. The water's dripping out. Right now we're at the point where the diameter is 2.4, which means that the height is also 2.4. And we want to know how quickly is the height changing at this instant. All right, so for a cone, and we're dealing with volume, so we're going to need a formula for volume. Now the formula for volume of a cone and volume of a pyramid are really the same thing. It's 1/3 capital B times H, where capital B is the area of the base. Now if we're dealing with a cone, the base is a circle, and the area for a circle is pi r squared. So I can rewrite this formula as 1/3 pi r squared h. Now some of you guys just memorized that formula, and that's fine, but if you want to just memorize fewer formulas, you can memorize the same formula for cone and for pyramid. And really it's the same formula for prism and cylinder, it's just got the 1/3 in front for cones and pyramids. All right, now right now I have 3 variables, but I only have 2 variables that we're dealing with in the problem. So we need to figure out a way to get rid of this r variable. Now I know that the diameter is equal to the height, but we don't have diameter in this problem. But we know that the diameter is the same as twice the radius. So we know that twice the radius would be equal to the height. I could plug in h equals 2r and figure out dr dt, but this problem is asking for dH dt, so it would be better to solve this for r. So divide both sides by 2, so r equals 1/2 h. The radius is half the height at any given time. So I can rewrite this problem as 1/3 pi times 1/2 h squared times h. So instead of the radius, I just plugged in half of the height. Now when you square it, make sure you square 1/2 as well. So 1/2 times 1/2 is 1/4. 1/4 times 1/3 altogether is going to be 1/12. We've still got a pi. H squared times h altogether is h cubed. At this point, now I only have 2 variables. When I take the derivative with respect to time, I'll get dV dt, and then I'll be able to find dH dt. So I'm going to go ahead and take the derivative with respect to time. The derivative of volume with respect to time is going to be 1/12 times 3 times pi times h squared times the derivative of h with respect to time. Now I can cancel this out and make it 1/4. And then to get dH dt by itself, I just need to divide both sides by this whole thing. So dH dt is going to be dV dt divided by 1/4 pi h squared. So I just divided the 1/4 pi h squared on both sides. Now I can actually plug in some numbers. So dV dt was negative 0.5, and then 1/4 times pi times h. Now we need to figure out what the h is. Now we knew that the diameter was 2.4, and luckily the diameter and the height are always the same. So I can just go ahead and say, okay, at this time, the height is also 2.4. Technically, I can just leave it like this. Since we have calculators right now, I'm going to go ahead and figure out the value. So dHdt would be negative 0.110524, and I'm going to put in some units. Height is measured in inches, time is measured in seconds. Now, the problem asked for the rate at which the water level is dropping. So the way that I would write my answer if this was the AP exam is I would say the water level is dropping at 0.111 inches per second. Now, you would probably get it right if you said it was dropping at negative 0.111 inches per second, or if you said the rate of change is negative 0.111. At somewhere in the problem, you need to specify that you know that it's dropping or it's becoming negative. So either the word dropping and then leaving your answer as positive or having a negative. There's a lot of different ways. And honestly, the AP exam probably would not create a situation where you would get it wrong if you didn't put that in. But it's good to always be thinking about attention to detail and what is actually going on in the problem. Now, technically for this problem, 0.110 or 0.111, both of those are acceptable because the AP exam is kind of weird. As long as you round correctly, you'll always get it right. Wait until the end of the problem to round, and make sure you always put at least 3 decimals. Also on this one, if you put 0.1 repeating, that would be wrong because it's not 0.1 repeating, even though our rounded answer is 0.111, so don't put that either. All right, hope this helped. Reach out to your instructor if you have questions. Thank you.